Good morning, everyone. In this particular video lecture, we will discuss some numerical questions on concept of inductance. Now, as you can see here, some important formula related to inductance. Now, if you want to calculate the value of voltage across inductance, then we have to use the formula, that is L into di by dt. Now, if you want to calculate the value of current, then we have to use the formula 1 by L1 into integration of v dt. And if you want to calculate the value of power across the inductor, then we have to use Li into di by dt. And if you want to find out the value of energy, then we have to basically use the formula integration from 0 to t p dt, that is 1 by 2 L into I square. And if you want to calculate the equivalent of inductance connected in series, then we have to use the formula L equivalent is equal to L1 plus L2 plus L3. And if you want to calculate the equivalent of inductance connected in parallel, then we have to use the formula. Here the formula is given for the two inductor, and if n number of inductor are connected, then basically we use the formula 1 by L1 plus 1 by L2 plus 1 by L3 plus dot 1 by Ln is equal to 1 by L equivalent. And if you want to calculate the value of here, this formula basically gives the current across the inductor 1, that is, this one is the current according to current division rule. The value of current across the inductor L1 is equal to I into L2 by L1 plus L2. And if you want to calculate the voltage across inductor 1 by voltage division rule, then its value will be V into L1 by L1 plus L2. Now, based on all these concepts, we are going to discuss some numerical question. Now, the first one is, as you can see here, the strength of current in 1 Henry inductance. Here the value of inductance is given, that is 1 Henry. Inductance changes at the rate of 1 ampere per second, means here the value of di by dt is also given. So we have noted it down, the value of di by dt. And now find the value, find the voltage across its end. As we know, the value of voltage is equal to V is equal to L into di by dt. So by putting the value of L and di by dt, we can find out the value of voltage across the inductor, that is V is equal to 1 volt. Now the next question, and determine the magnitude of energy stored in the inductance after 2 seconds. Here the timing given is 2 seconds. Now as we know, energy stored in inductance is denoted by E, and which equals to half Li square. Now here we have to find out the value of current, and also we know that the value of current across inductor is equals to 1 by L1 into integration of V dt. So here we can find out the value of current, and it will come 2 ampere. Now as we put the value of inductance and current in this formula, we will get the amount of energy stored in 2 seconds, and it will be equal to 2 joule. Now the next question, that is the current and voltage profile of an element versus time has been shown in a figure. Determine the element and find the value. Now as you can see here, there are two graphs. The first one is current versus time, and the second one is voltage versus time. Now friends, from this graph, as you can see, the value of voltage is not changing, means it is constant. Means the element is restricting the change in voltage. And as we know, inductor is an element which basically restricts the sudden change in voltage. So from this only we can say that the element is inductor. Now as you can see here, by observation we can say that the element is inductor. Now here we will have to find out the value of inductance L. Now as we know, as you can see here, the value of di by dt is also given, and the value of inductance is basically we have to find out. Here the value of voltage is 2 volt. Now as we calculate, then you can see here V is equal to L into di by dt, and the value of voltage is 2, and the value of L is we have to calculate, and di by dt, as you can see here, the value of here the value of timing is also given, 5 into 10 to the power minus 3 second. So here we have put the value of di by dt, and now as you calculate this both get multiplied, and the value of L becomes 10 into 10 to the power minus 3, that is 10 to the power minus 2 Henry, that is 0.01 Henry. Now friends, the next question, that is three pure inductor as shown in the figure are connected, find the equivalent inductance. Now friends, as you can see here, it is very simple that we have to find out the equivalent inductance. Now as you can see here, this combination is in parallel, and its equivalent inductance, that is the equivalent amount of inductance between x and y terminal will be equal to this one is in series with the equivalent of this one, and this one is also in series. So we can say that all these three are in series. So here, as you can see here, 2 plus the combination of 4 parallel 4 is in series with 2 ohm, and is also in series with 1 ohm, 1 Henry. So as you can see here, 2 Henry plus 4 parallel 4 Henry and plus 1 Henry. Now if you calculate all this, then its equivalent will be 5 Henry. Now friends, the next question, that is this one is so simple. We have to calculate the value of equivalent value of inductance between terminal x and y. Now as you can see here, all the inductance are in series, so basically we add them, and the value of L equivalent will be 16 Henry. We can use the formula for N also, where N is basically the we can use the formula for N, yes, where N is basically the number of inductance. As you can see, the number of inductance are 4, then 4 into 4 will be basically 16 Henry. Now this is basically the numerical questions based on the concept of inductance.